Bonjour tout le monde, merci. Je parle un peu français, mais I'm going to talk in English because that's easier for me. Hope you don't mind. But thank you very much for the warm welcome. How many of you are using Kubernetes today? Quite a lot of you, okay. And how many of you are responsible for deploying Kubernetes in your organization? Okay, right. Pay attention. So I'm going to talk this morning about the state of Kubernetes security. And I want to try and highlight some things that, particularly those of you who just had your hands up, probably should be aware of, and hopefully give you some guidance to operating your Kubernetes deployments safely and securely. And why do we need to worry about this? We need to worry because, unfortunately, there are people out there who will try to attack your deployments. And there are lots of different ways that they can approach attacking a Kubernetes cluster because it's a complex system. There are lots of different APIs, there's lots of different moving parts, it's distributed, and with that complexity comes a lot of opportunity for attackers to find ways in, or potentially find ways into your cluster, particularly if you've set things up in an insecure way, or you've done something a little bit foolish. Probably around 18 months ago, somebody did something pretty foolish, and that somebody was Tesla. And they had configured their Kubernetes cluster to expose the dashboard to the internet. And somebody found it, and they used Tesla's deployment to do cryptocurrency mining. Now, things have moved on a long, long way since then. Since this happened, a lot of the defaults have improved dramatically. And, for example, the dashboard isn't even installed by default. So you probably aren't in the same situation as Tesla were 18 months ago. But, you know, best to be sure, right? Okay, so while the dashboard is not available for easy attack, there are potentially ways that you might configure your control plane components in an insecure fashion. There are lots of components to Kubernetes. There are APIs into those components. When you install Kubernetes, you get to control some of the parameters for these components, and some of those parameters would allow your Kubernetes cluster to be running in an insecure fashion. If you're using something like kubeadm to install Kubernetes, actually the defaults these days are pretty good, and they're getting better and better with every release. But there are things to be aware of. Maybe you've installed your Kubernetes a year ago, or perhaps you're using different installation tools. Maybe you're not using the default settings. And in that case, you need to be a little bit careful to make sure you're not using insecure settings. And there are a lot of settings. Fortunately, there is some guidance available in the form of the CIS Kubernetes Benchmark. Who's heard of the CIS, Center for Internet Security? Okay, not many hands, right. So the CIS produce benchmarks for lots of different pieces of software, particularly server software. And these benchmarks tell you how to check whether that software is configured securely, according to best practices. The specs, the benchmarks themselves are written by community. So I'm actually one of the co-authors on the Kubernetes benchmark. And if you want to get involved in helping figure out what secure settings should be, you can join the CIS. It's like any other kind of open community. You can get involved. So the CIS has written this Kubernetes benchmark, and it's probably 200 pages of tests that will tell you things like, have you configured your server components to use certificates? Have you left the insecure port open? It's probably not a good idea. So there's a large number of tests described in this CIS benchmark. my team actually wrote a tool called KubeBench that you can use to check whether your Kubernetes deployment matches the settings that are recommended in the CIS Benchmark. And that's become quite a popular way of checking for the most secure settings. So that's a recommendation. Use a tool like KubeBench to check your host configurations. Now, unfortunately, not everything about security is under your control. So there are settings you can make that cause your cluster to be insecure, but there are also just bugs that can cause software to be insecure. This was the first vulnerability, the first critical vulnerability in Kubernetes. And this was discovered just before KubeCon in Seattle last November. Was anybody here in Seattle in November? Okay. So this, at the time, was kind of, I don't know, interesting news. And the story behind how it was discovered was really good. If you look up the Rancher blog, Darren Shepherd wrote a great blog about the background to this vulnerability. And it was really the first test for the Kubernetes security team. So there is a group of volunteers from across the community who respond when someone reports a potential vulnerability in Kubernetes. So Darren from Rancher found this issue. He sent it to the security team. They produced a fix in pretty short order. And the fix was announced at the same time as the vulnerability was announced. Do you need to worry about this? Well, basically, all you need to worry about is making sure you have up-to-date versions of Kubernetes. As soon as the problem was reported, the patch was also reported, and basically the task was go out and update your Kubernetes deployment. Make sure you're running with the latest fix that includes the fix for this problem. Shortly after that, there was another vulnerability reported. This one wasn't as problematic, but it gave people another reason to update their Kubernetes cluster pretty quickly. So the lesson here is keep an eye on whether there have been security patches, keep your cluster up to date. The fact that these problems are found is not something to worry about. It's inevitable that in a system as complicated as Kubernetes, there will be bugs, and some of those bugs will have security implications. The thing to be impressed about is how quickly the community responds and how all you need to do is keep up to date with the latest release of Kubernetes. You don't need to worry too much about the details of those fixes. So let's say you've kept your Kubernetes cluster up to date, you're paying attention when new releases come out, and you're deploying quickly. And let's say you're also following those CIS benchmark guidelines. There are a couple of things that are kind of interesting, and I would say the community is not 100% agreed on how to handle these questions, these conundrums. So the first is about whether or not you should allow privileged containers in your cluster. So the CIS guidelines, the benchmark, says you shouldn't let people run privileged containers in your cluster. But you almost certainly can't comply with that as a blanket rule because some components, like kubedns, need that privileged access. So while the guideline says just don't allow privileged containers, the reality is you probably need to allow some exceptions. Another example where it's still, possibly up for debate is whether or not you allow anonymous access to the Kubernetes API. So this is basically, do you let people make requests to the API without identifying themselves? The CIS guideline on this has just changed because the thinking today is you should use RBAC to control who is allowed to do what in your Kubernetes cluster, but that you should be allowed to do anonymous requests just so you can do things like health checks, because not every component that needs to do a health check or service discovery should necessarily have to be configured with an identity. That's the thinking. You may decide you actually don't want to allow anonymous API access, and if you do that, you'll have to provide identities for every component that wants to do health checks and service discovery. So how do you provide this identity? That kind of leads us neatly onto the questions of authentication and authorization. So authentication is the step where you identify yourself, or your user identifies yourself. There's actually no such thing as a user, as a first-class resource at least, in Kubernetes. Users and groups, these identities are all defined, they're expected that they're going to be defined outside of Kubernetes. Maybe it's using your corporate directory, that maybe there's an integration with LDAP. But there are a variety of different authorization plugins that allow you to get identities from an external provider. Once you've got the identity of someone, so that's the authentication part, you then need to figure out what that person is allowed to do. That's the authorization part. I know who you are, I now need to figure out what you're allowed to do. There are a few different authorization mechanisms, options in Kubernetes. You definitely want node authorization turned on, otherwise your kubelet needs to identify itself and be allowed to do things. You probably shouldn't be using ABAC anymore. That's the kind of old-fashioned way of doing access control. RBAC is where it's at now, so there's a lot of assumption in some of the guidelines that you're using RBAC. If you're using Kubernetes, how many of you are using RBAC today? Okay, I think a few more of you probably should be looking at RBAC, unless you're doing something even more sophisticated, which is the possibility of using your own webhook, or maybe Open Policy Agent. There's a project called Gatekeeper that is still pretty new, but this would be looking at, I'm not going to say necessarily replacing RBAC, but you could theoretically replace RBAC with your own authorization and policy agents. RBAC gives you some abstractions around permissions. So you have resources, things like pods or deployments or nodes or any kind of object. And if we were talking about Linux, you might say that users have permissions to read, write, and execute a file. That's how permissions work in Linux. In Kubernetes, there's no direct connection between users and the thing, the resource. We have these abstractions called roles. The role describes what operations are permitted on a particular type of resource. Roles don't say anything about who can do things. The who part is added by role bindings. Role binding associates a user or a group or a service account, which is an internal identity, with the role. So you kind of have to get to grips with this, these abstractions in RBAC. You can have cluster-wide roles, so cluster roles, cluster role bindings, or you can have namespace-specific roles. And this is definitely worth looking into and getting set up in your cluster. Okay, so far I've kind of talked about things that are all to do with how you configure and run your Kubernetes cluster. Not talked at all about the software you're running inside that cluster. So now we're going to talk a bit about your application code. And this kind of touches a bit on what Dan was talking about around the delivering safe software. you're delivering software in the form of, or deploying software in the form of container images, and there are some best practices that you should really be at least aware of and probably actually doing. A lot of organizations want their containers to be based on particular trusted base images. In your Docker file, you define what that base image is. It's a good idea not to run containers as root. And one way to do that is to define a user inside a Docker file. There are some other things about running as root that I'll come to in a moment. If there's one thing that I would say you should do to improve the security of your deployment, if you only did one thing, it would be to have vulnerability scanning. I don't care, even if you don't get it from Aqua, just get some vulnerability scanning. There are plenty of free and open source options out there to scan your images for vulnerabilities. And the reason why this is so important is if you just deploy software and you don't know whether it's got any vulnerabilities in it, attackers can exploit. You could be running with shell shock or heartbleed or any number of critical vulnerabilities that allow attackers to get into your cluster. And once they get into your cluster, particularly if you're running as root, bad things can happen. So if you do one thing, do some vulnerability scanning. Most of the organizations that I come across these days are using private registries, so they're not just pulling images from a registry open on the internet. They are typically operating their own registry, so they've got more control over what's going into that registry and have more security, more confidence in the security of that registry. Kind of also includes things like managed registries. So how many of you are on a managed Kubernetes like EKS or GKE, something like that? Yeah, a few of you. So you're probably using the managed registry that comes with those services. Those count as private. And then the last thing on this slide about good practices for container images is the idea of knowing what your dependencies are, having some way to try to reproduce a build the best you can. There are projects like Bazel that are intentionally trying to make builds reproducible, but even if what you're doing is just knowing which versions of packages you're pulling into your images, that's a good thing from an image management point of view. So having got your container image built with kind of good configuration, good practices, we then need to run those containers. Don't run your containers as root if you possibly can avoid it. Root inside a container is the same identity as root on the host. Now, it's not easy to escape a container. But if you do have some way of escaping a container, and there are ways of escaping containers that have popped up from time to time, if something happens and your containers are running as root, and if they've been compromised, as soon as they can break out, the attacker has root access on your cluster. So try to avoid letting containers run as root if you possibly can. And you can do that with describing or specifying a user in the Docker file. You can also use the Kubernetes pod spec field, run as user. You can put that into a pod security policy. You might also want to limit the mounts that a container is allowed to run with. The extreme of a bad mount would be to mount the host root directory into a running container. There's nothing to stop you from doing that unless you explicitly prevent it. You could do that with things like Open Policy Agent. You can do that with pod security policy. You may want to also look at things like network policies that let you restrict which pods can speak to each other. You may want to look at restricting or limiting runtime rules with Linux security modules like SE Linux or AppArmor, or with seccomp profiles. Incidentally, how many of you have been running with Docker? How many of you have used Docker in the past? Yeah, I would expect most of you, right? So when you run a container in Docker, by default, it has a seccomp profile that's actually pretty good. Seccomp profile limits what the container is allowed to do in terms of system calls. And the default profile, you probably never even noticed it, like 99% of containers can run under the default Docker seccomp profile with no problems at all. And so you may well think that if you go from running your container on Docker to running in Kubernetes, and maybe you're using Docker as your runtime, you might assume that you're getting that default seccomp profile. You are not. If you want that seccomp profile, you have to explicitly specify it in Kubernetes, even if you're using Docker as the runtime, which is kind of weird, but that's how it is. All right, some more CVEs. So this one was actually a container escape that was briefly possible. So you know what I was saying about you don't want to run as root because occasionally issues come up that allow container escapes, and if you're running as root, that would be bad. In this case, just update your Kubernetes release. There is another, even more recent one that came out in the last, I'm going to say, week or so. And this is, I kind of almost think this is funny, that you're going to run a container as a non-root user, and that's all fine. But if the container gets restarted, or you start a new pod on the same node, even though the first one's running as non-root, the second one will run as root, which is not ideal. This one isn't, as far as I know, at least when I looked it up yesterday, there wasn't a fix for this, but you can mitigate it by using rules like run as user. This isn't actually considered terribly serious. It's considered a medium vulnerability. But it's kind of interesting that at this point in the kind of history of Kubernetes, we are seeing vulnerabilities that can be mitigated by using all these controls like run as user, but nonetheless, interesting kind of interesting state of affairs. The last thing I wanted to talk about in terms of what you can do to run your cluster securely is secrets. So by secrets, I'm thinking about things like the tokens that you use to access databases, or credentials rather, that you might use to access databases or other components within your deployment. Basically, the secret information that your software needs in order to run, to do its job. And there is an object called a secret in Kubernetes. So you can use that. There are some things to be aware of, though. So they're namespaced, which is nice. They're objects. They define a secret, some secret data that gets passed into the container, either in the form of an environment variable or mounted into the pod into a kind of well-known file location. One thing that you really want your secrets to be is encrypted. You want them to be encrypted whenever they're written to disk. You want them to be encrypted whenever they're in transit. If they're available in the clear when they're written to disk or when they're in transit, then there is a risk that if there is an attacker who is on your cluster somewhere, you've made it easy for them. So you want them to be encrypted. The only place you want secrets to be unencrypted is in memory when they're in use. The reason why I'm saying this is because when you pass a secret as a file in a volume, it's actually written to a temporary file system. So it's actually only held in memory, which is good. The thing that you need to know about secrets in Kubernetes is that by default, they are not encrypted. They're just base64 encoded. So it's kind of made it difficult for you to read as a human, but it's not encrypted in any fashion by default. So you either need to enable encryption of your etcd store, which you can do, or you can use a third-party tool. I think it's quite common to use tools like Vault or like the key management systems on your managed deployment. You know, your managed cloud provider may have key management, secrets management that integrates with Kubernetes. You want to do one of those things, because if you're not doing one of those things, your secrets are not encrypted. Anybody who can get into your cluster, anybody who has access to your cluster can read an unencrypted secret. So I've talked about a few things that I would recommend that you do to keep your Kubernetes cluster safe. Simple things like just keeping your Kubernetes components up to date, stay up to date with releases as they happen. Use tools, Kubench is an option for checking that the configuration is secure. Vulnerability scanning in your images. As I say, that would be the one thing I recommend above all else. Try to avoid running your containers as root, and use RBAC, role-based access control, to restrict who can do what on your cluster. And finally, manage those secret credentials carefully. If you do those things, your cluster should be in a pretty good state. Nobody in security ever says that things are secure. They just say that things are more secure or less secure. If you want to find out more about Kubernetes security, I was a co-author of a book with Michael Hausenblas about Kubernetes security. You can download that for free from the Aqua website, but we also have a few copies. I don't think we have enough copies for everyone, so we'll have to figure out some kind of, I don't know how you do that. But yeah, there are a few going to be available on the Aqua stand downstairs. So do go and say hi to my colleagues there. And if you have any questions about Kubernetes security, we are more than happy to help. Thank you very much.